stuff, what I think we struggle with is sort of, okay, and you've done a good job of integrating, significant, um, to frac modeling and, and, well, it's frac modeling, I guess, is putting it in a digestible, although a lot of chewing for me to, and, this integration of what else can you integrate it with, your point, Ryan, Boshang's done a lot of RTA. I mean, there's stuff in Whitson that they can
Well,
dump
and
out.
that's that's a thing. Like I know those guys are probably slammed right now, but like
Oh, they are.
if we can find someone that's got access to that, you can probably get in there and just, either just write it down by hand or something, or dump the analysis out of the program into an Excel sheet. And then once it's there, then, David can grab it and he doesn't have to, fight with it. It's there. You can pull it right into that Spotfire project that you had with the Roussel stuff. And then, take the Revochem thing, do the same thing. Right now, you've got all the data in one place.
Yeah.
Yeah, I mean, it's doable. It's just, they just set up a data link.
And the Revochem data is already in there, right? Didn't they already put that in Spotfire?
We've got
did that, right?
Cody actually has a really fairly powerful. It's a little overwhelming Spotfire project. I had it open here. If I can find it.
So the trick is, because like it's easy to have things in these standalone Spotfire projects, but like if we have Revochem, as a data field and like WellView or Snowflake or whatever kind of database, so that we can have an info link. Then what happens is that table is really easy to add to any other project that we have. Anyway, so I might have to poke on him and see if they've already set up a data link, because then that makes it easy.
I poked Tim, right? Tim probably has access to all this stuff. It could tell you in a second, like, yeah, absolutely. Here's how you hook into it.
Yeah. I'm speaking out of this. We're going heavy into Snowflake. That's all I know. And to the point where if the data can't talk to Snowflake, we're not going to use the platform. I mean, we're not there yet, but so anyway, I don't want to. But this is Cody's Spotfire project and it's really slow to load, but it brings in production data in with the time-lapse geochemistry Revochem data. There's I can't even navigate this thing, but anyway, the stuff is getting populated in all of these Spotfire projects with clever guys that can do Python and that.
Well, Doug, that's one of the reasons I invited Tube here is he's got experience with Python programming as a petroleum engineer, right? So if you've got any interesting projects that you would like to throw our way, I'm sure that he would be more than happy to start coding some cool stuff up.
Okay. Anyway, I don't know where I want. I did want to get some input from you guys on some stuff, but let's see here. Anything else you wanted to tell us about, David? Right?
No, that's the gist for now. You hear I got this baby in the background.
Yeah, I want to go through something that's been chewing up a lot of my time.
Doug, just to stop you really here, just for a moment,
Sure.
as a sidebar, David just said he's got a baby in the background. So I just got a message from this guy. Maybe you know him. His name is Grant Spencer. He sent me a WhatsApp. He says, "Hey, hope you and Johnny Mac had a fun down under. Had a pint the other day with a few of the Petro community here, Tyler and Gord, right?" And he says, "How is your baby? Can you share some details, weight, size, eye color?" There, Doug.
Did I spill the beans?
Beans are all over the floor, Doug. I'm slipping on them, stepping on
them. We're all waiting for you. We're all waiting to buy your program.
The baby.
Yes. Anyway, inside joke. Okay, I'm gonna say I want to quickly go through this, but you guys can, I think, all follow this. But so, what do we got here? We got a DSU map. Maybe start with the map. We got this development, bunch of horizontals here, midway development. So these black lines are all the horizontals targeted from Wolf Camp to Joe Mill to Middle Sprayberry. This is the shallowest bench. So all these black guys. Well, these red guys are all SWD shallow injectors. The darker red band is the perf interval for the injection volumes, which I don't know, but I'm guessing they're 20 to 25 million, maybe on the upside, and several million maybe on the low side.
So Doug, just help me out a little bit here too, because I'm a little bit slow on the uptake on some of this.
Okay.
These wells, you guys permitted them, drilled them, you're dumping water in that you're producing, right?
Yes.
And what are the wells generally, like what are the rates on these things per day? Do you know?
I don't know. I mean, that we have all of that data, but
well, I mean, just generally, like I'm curious as to about what they're permitted at.
It's usually about 1,000 barrels per day.
How much?
It's
so I think the permits, the highest permits, usually go on like the deep SWDs. They can go as high as like 20,000 a day on some of the old ones, but most of them are like 1,000 barrels per day
on the shallow.
Yeah.
Yeah.
So 1,000 barrels a day maximum, but you could inject that any way you want, right? You could inject it at 1,000 barrels a minute if it would take it for 1 minute and then just shut the well down, right? You're done. That's legal.
Well, that's what they do because like for most of them, it's like it's actually the most incredible like RTA experiment ever done because the truck shows up and it'll unload its water and then like you see like the pressure transient go up as expected, just like they were running like a fit test. And then the truck moves on and the next one pulls up.
I've logged several injection wells and, you know, and they do, you know, in places where they log them, then do shut-ins and then do full, you know, to see if there's skin and then compare a string shot and or acid job. I mean, you manage it like you manage a reservoir. And, but, you know, anyway, I know a lot of we just dump until pressure builds up and then they probably do some acidizing and some remediation. But anyway, we're getting into the weeds. But anyway, I'm still clarifying. So anyway, all these injection zones, these two that go, well, three actually go deeper. I know these ones were existing producing Wolfberry wells. One went down all the way to the lower Sprayberry, quite into the Joe Mill, and this one went to the middle Sprayberry. So they're potential problem wells, you know, that, you know, and this is getting into cement and, you know, what's going on here. So this Midway water well is produced, you know, 5,000 barrels a day of water with almost no oil, although there was oil on that. So this was deemed, you know, the Middle Sprayberry is wet. So anyway, we'll get to that. But anyway, I think you understand this is, you know, we have lots of areas like this with multiple injections. This is probably one of the denser SWD areas of interest. So, and I won't get into the weeds on this, but they had me look at all the cement bond logs and try to estimate top of cement, which is really not, it's, you know, nomenclature is important. It's evidence of cement. Top of cement is, so I broke that down as there's evidence of cement, should be changed. Interpreted hydraulic isolation, where do you have enough cement of enough quality that would stop fluid flow within that well bore? So that's blue, and then the red is injection interval, and then intermediate casing points for these wells, which were all sort of not all deeper set. Okay, you got that? Next ones are all sort of looking at the same thing, maybe in a little bit different views. Okay, so this is this Middle Sprayberry Midway well, which happens to be right beside a non-marked SWD that we drilled, or a pilot well that Endeavor drilled right about here in 2024. So I'm going to jump to that. Well, before that,
Just a curious question, like, are you making all these slides yourself?
no, Hannah made these ones.
How are they making these, I wonder? Like, how are they making these graphics with the injection intervals and stuff? Is this coming out of like the Spotfire thing or what?
I don't know. They, you know, Hannah's team has been deep into this for a while. It's part of the AFE process now that, you know, if we have significant areas
Yeah.
of SWD, we want to highlight those before we drill, which was good. That's a really good point in that we're trying to get ahead of managing expectations. So on managing expectations, this is my little simple graph of failure mechanisms of possible injection into producing horizontals. So, sorry, my graphic, these should be turned 90 degrees, but hopefully you get the point. But if you're injecting into this SWD at 1,000 barrels and you got 25 million barrels stacked into this injection zone, and if it's hydraulically isolated in the well bore that you're injecting into, it can only go into the zone, and then it goes over here. If this strata goes over to this well and is, you know, the intermediate is cemented and your long string is cemented, you got no issues. If you go over to this well over here and you don't have cement over the intermediate, but you do have top of cement, this should be, I should change this to hydraulic isolation, but the water can dump into here and go wherever it wants to go, but you're exposed to corrosion.
A quick question on that too, like, I'm not 100% familiar with your completions group. Are you guys doing long strings on all your wells?
I'm saying I should change this, the production casing and the intermediates.
Basically.
Basically, we have some fairly poor practices in that we set a lot of for the shallow, like MSs or JMs, we set this intermediate usually in the clear, well, it can be in the lower.
That's generous.
Lower.
Well, yeah, but I mean,
lower
like,
St.
one of the things I'm trying to get at is you're not setting liner hangers or anything and trying to cement the whole. Yeah.
No. We have this. I painstakingly went through all of these. These are particular wells. Actually, they're close to the actual depths. We set this intermediate very close to the injection, and a lot of times the injection zone is below.
So when you're circulating back up, you're circulating through the injection zones, what you're saying.
And you're what?
When you're circulating the cement on that intermediate, you're circulating up through the ejection interval.
So drilling knows that they have, challenges and they might, you got downflow going down here, like you guys know the cementing process, but for cementing this string here, if you got injection and it is coming into this wellbore, they know it when they drill it, that, we have losses, we have gains, it's difficult to drill it. We went through a whole fishing job a couple months ago, but it's very hard to cement this. If you got water flowing down here, which when you run the casing, you pump cement around here, it's gonna get, well, if it's here, like this well, trying to cement this, this string here, you got this flow coming down. It's going to contaminate the cement. The cement can't go any deeper than the hole that you drilled, but it's going to be contaminated. You might get cement returns, you might not. It's going to be pretty shitty cement. You got this extra. I mean, I work with cement. You do a slump test, too much water. Well, you put water in, you got to pump it as a slurry, and then it gets diluted here. So they're trying to use some different cements that set up faster, but that doesn't, there's physics here that's really challenging to get a good cement job. So, one of the things is, well, run these things deeper so you're further away from the injection zone. It's still going to be a problem in my mind. So, we've argued about, oh, run these intermediates deeper. And I'm going, if you got water flow there, you're adding money and probably not necessarily getting a better cement job. And we do not measure the cement. We do not run CBLs on intermediates, which is if you're.
So what about all this whole planning process with the injection team? Like, aren't they advocating for that at all?
Well, we have identified. We're trying to tiptoe. We're trying to advocate with data. That was, this is the whole premise of me looking at all these cement bond logs. Evaluate and I can only evaluate the production string because that's the only data that we have. But we're pointing to some of these failure mechanisms and soft dialogue to drilling. Who knows that this is an issue, but they're so far down the factory line of got to drill wells, drill them cheap, and if no one comes back with identifying these failure mechanisms, and we're not going to change anything. We are hard. There's a full court press with drilling looking at this stuff and production looking at this stuff. The SWD team involved, I'm involved. So anyway, this is on the right is the worst case scenario where you don't have cement on your production string. You're not contained in your injection zone, and you basically get dumped. You can get potentially dump flooded all the way. So here's that DSU in that we had. This is an LS well on the left and 2 JMs on the right. The MS was okay producer, say okay. It produced oil. You can't see, I mean, it's 500 barrels a day, whatever, with this, whatever water oil ratio. These 2 JMs, and these are scaled the same on water and oil. It's got a lot more water and basically no oil. So I looked at the cement bond log. I said, there is poor cement, no hydraulic isolation, so we squeezed. Oh, this is the squeeze. You can't see, there's a little bit of oil here. So I went, fuck. Sorry, excuse my language. We're early on. This is maybe a couple, well, no, this is maybe a month in, and the water went down. The water went down quite a bit, but the oil didn't increase. So failure, spend a lot of money, maybe the jury's still out, but here's the interesting thing that I've talked to Ryan about, and this, I'll start over here. Sorry, I don't know if you can see my mouse, but these gamma ray tracks is, the red one is the CBL, the green one is the MWD gamma ray, and they pretty much overlay on the LS well. This is just the amplitude from the cement bond log. It was a good cement job. Over here on this JM, you see this gamma ray from the CBL elevated from the base of the intermediate casing all the way along the production string. It's kind of it elevated a lot. There's a third gamma ray on here, and the second CBL that we ran after the squeeze, which I think what's happening is the squeeze cement has pushed out, and this excess gamma ray, I believe, is the salts dropping out as the pressure is dropping, being actively dump flooded down this well.
So let me kind of stop you right here. David, you remember we did a bunch of stuff at Apache, right? Where we were seeing like the toe or the heels rather, or the wells, where you had dump flooding and stuff, and you had really high uranium salts precipitating out at the perfs. And we had gamma ray logs, and then like Craig was looking at some of that stuff at 1.2, right?
This is, I'm going back 40 years, well, not quite, because I logged Keystone probably 3 years into my tenure, but I was tying in cement bond logs, and I was going, hey, what the hell is going on here? Right at this point, the gamma ray's taken off, and they went, oh, that's the perfs. These are, gas wells that produce some water, and over time, it was, it's a little water production log. So this is a well, it's well documented. I actually did my little online, deeper dive into the actual physics of what causes this. So that I'm a practical, sometimes petrophysicist use this. I think it's really telling and interesting. This well does not seem to have that issue, even though there's poor cement there. So I call this active dump flooding. This one's active. This one's, didn't get to the well bore for whatever reason. I don't know. So here is something that so these are two wells that we had logs on. This brown one here was logged in 2024, and it's right close to that deep injector here. And this black one was logged in 2014, so 10 years earlier. And I just I overlaid, so the black curve is the resistivity off of this guy, and the blue is this later one, 10 years later. And these are both induction logs. They are, so my interpretation is this is beyond, I don't want to get, this is beyond what the measurement, I call it the measurement uncertainty would be. And I'm going, this is interesting. This is the Middle Sprayberry. This is the organic mudstone. These are the silts. This is organic mudstone. This is organic mudstone. And I'm going, that's quite a difference. And I'm going, what could this mean? So my hypothesis is these could be fractured organic mudstones, oil wet. I'm pretty sure, these organic mudstones are oil wet, and it's easier to put water through that kind of system than a water wet system. And, I'm saying this is possibly these bad boys here that have injection into them are actually have been dump flooding this area for now. What I've asked the SWD team for is, when did these start injecting? Give me a date of the start of each one of these and the volumes. Because it comes down to the volumes of, what's been put in there. But I do know that if you're injecting at 10 ppg and these formations are at, effective pressures, you're 10 ppg and you're at 8 here in the Middle Sprayberry and or Upper Sprayberry, you're going to have flow that way if there's a pathway to get there. So I think this has been actively dump flooded, and that's that. So if I'm right, this is potentially, if you have the data, you can manage expectations. Don't drill it. Drill it with expectations. But you do need, good cement on whatever wells you're drilling to make sure you're not getting active dump flooding. But you can't do anything about what's been flooded already.
So Doug, fun fact about that Mighty Mo, which I think are the scariest ones, is I think it was swapped from deep to shallow.
I don't even know. Yeah, we don't even have. Interesting. We don't have that one as an active. I don't know what the activity is on that.
Yeah, well, what's
That
wild
one.
about it is when they drilled an offset WD, that well ballooned like crazy.
So here's I should have put it in this. Okay, we're going. So these were those two wells that I compared to, and then I added two more over on the right. They're in a DSU that we're deciding whether or not we're going to drill JMs in these wells because of this. Is it water? Is it wet? Is it is it been dump flooded? So I did this really quickly. I overlaid that 2014 well with these other ones. Now they are 4 years younger or older, I guess, than this Mighty Mo. So they might not have been, if all the injection was due to Mighty Mo injection, these ones might not have been, when we logged it, might not have been as effective. So they sort of overlay there. You don't see this bigger discrepancy in the MS. And it's, when you look at it at this scale, you're going, Doug, Brian's going to go, these aren't calibrated right. Logs are wrong. I say they're right. I say this is telling us something. So my boss, when he saw the work that I did on this on Sunday, he said, "Oh, do this yesterday on these other wells, so we can decide today whether or not we're going to drill these JM wells." And there's sort of a lot. So this is my worst case scenario is these deeper SWDs that might not have cement in them, or yeah, that we've dump flooded wherever it can go. It's going to go into the Upper Sprayberry. It should go into the Upper Sprayberry first, or if there's any fractures, the fractures are Darcy perm. So if it's at lower pressure and you've got pathway to that place, it's gonna go there for sure. I don't think many people can argue that statement, and I think this is what physically is going on. Can we estimate these areas? I think we can. One is, and it's something that just does not seem to get I need help with, is that where this mapping this excess gamma ray. Now, if we have a lot of old verticals around and they were actively being dump flooded, you know, we potentially got sort of this potential time lapse of the, and I think even you could probably back of the envelope estimate how much water based on this difference here. Anyway, so we got a problem. We know that we got a water problem. It always seems to come back to geology. Oh, these are wet zones. I'm going, they're not freaking wet. I mean, they should produce oil. Now it comes down to pressure relative perm, you know, which is water saturation. You know, I've tested lots of wells and I go, there's oil there, but it produced only water in conventionals. That, you know, just because there's oil there doesn't mean it will produce oil. It comes down to relative permeability. So, you know, I'm not saying there's no geology effect here. It's all 100% dump flooding, but I think it's hard to argue to me these JMs. I mean, there's offset JMs that produce, okay, here's, I mean, this just, these are offset. Okay, this is the Middle Sprayberry well that's real proximal to that that Midway SWD well. So this produced oil. It actually produced 150 barrels a day of oil and then went to 20, you know, and it's 5,000 barrels a day of water flat. You know, and then some gas. So this is a JM well. You know, that's, you know, I look at the logs here to the ones that are 100% wet, and this is what it should do, 500 barrels a day. Is it a great well? No. This might have been actively water flooded as well, but it's not got active water flood that's just creating zero value for us, negative value. Anyway, to me, you can't have this JM and then a wet one right beside it. Not in this geology, not in the basin, not where we are. You know, all things are possible. Some things more likely. There's no major fault here. There's no like. Anyway, that's my story, and I'm sticking to it until you guys pull it apart. All sorts of pit pressures. Anyway.
I'll have to think deeply, Doug. I actually got to run.
Okay.
But thank you, gentlemen.
All right.
There we go. That's my complainer one.
Okay, I got one.
Have a good one.
I got one ask of Brian before we go.
All right.
I sent you a blind CC on some stuff that we're seeing if we can use AI to do cement interpretation. And I'm struggling with just even demonstrating what I think I can do, but I would need some, and I would fill out a petrophysical request form so they can go through the proper channels. But I don't know if you've had a chance to digest what I was trying to do with
Well, like I
this.
said before, you know, if we can get the data, we can start to play with it.
Yeah.
But we need to get the data.
Okay. Well, maybe I'm going to fill out a petrophysical request form, and then I'll share. I got these wells. I got several loaded that we can test this out. But anyway, I won't get into the weeds. But I'm just trying to do simple multi-line formula to plot this stuff up, and I'm struggling just with that. But anyway, well, I'll formulate it a little better so you can digest it, and the powers that can be, you can decide we'll use you for something and whatever.
Well, like I say, if you give me the data, I'd be more than happy to load it up in this new software and stuff and have a look at it and see what we can do with cleaning it up and making some difference maps and stuff like that, you know, looking at sort of normalizing that gamma ray and then taking, these areas where you've got the differences,
Yeah.
and making some plots of that by zone. I mean, you've got a lot of information here that's very useful, right? You've got the tops, you've got the log data, you've got wellbore information. All we have to do is tie those things together.
Yeah. I think it can be very powerful. We get more data and we can analyze it quickly. We can assess risk, and my experience with fixing remedial cement jobs is high risk, low success, and and that's why drilling usually sort of gets away with that's good enough. You guys are not gonna, we can't fix it. You got to live with it. Blame geology and move on, and that's fine until it becomes. And just sort of, not full disclosure, but I do think differently now that I've been at Diamondback for 7 years. Is you there's they're going, yep, this is drilling. Yep, problem. The problem on 8 or 9 wells last year out of 400. Not really going to think too hard about it. And I think, and actually, that's sort of okay. Yet we still want to, I think, identify these areas and see if we can do something about it, because production is, I think their number is slightly different about the number of wells, and it's not just cement, it's holes in casing, that are related to, guess what, no cement and nasty fluids behind pipe. So, this is a problem that will get worse, but I don't, the economics of it is not sort of, well, it's sort of straightforward, but I try to use the economics of, if we're deciding, like, we're not going to drill JM wells because we can't, we've got active dump flooding. Well, that is fixable. That, not, you don't want to squeeze it, you want to fix it and have it done right the first time, however you can, spending a little bit of money, but if it's $500,000, that will come into the economics, and depending on the price of oil, you go and don't drill it. Or now today we drill anything, but anyway, jumping around from open hole, cased hole, production, SWDs. So we welcome any reservoir engineering input. This is a question for, sorry, how do you say your name? Arcadet? Yeah. One of the things that I've wondered about with, it's sort of post-mortem, but looking at these wells like that, go back. When you look at this, this well that is deemed to be a wet Middle Sprayberry strata is, by the data, yeah, you got 5,000 barrels a day of water, but this reservoir cannot, the reservoir that we are trying to develop is being, I say it's being actively dump flooded and it's not a wet reservoir. What can we get out of the pressure transient or rate transient to go, hey, this is just excess water coming from somewhere else. And we have enough data on these reservoirs that I know I'm pretty sure that this thing should produce 500 barrels a day of oil with maybe less water. It sort of comes down to a productivity index of the whole fluids. And I look at that a lot of times. I go, all right, you're saying this is a wet well. It's producing 6,000 barrels a day of water. If you add the oil, maybe let's just give it, it's 5,500 barrels a day of fluid. And then you look at a good well there, and it's producing total fluids of 4,000, but half of that is oil. I'm going that there's an extra flow capacity in the well that's wet, and I'm going, that's not, that's physically possible because you got this water coming from somewhere else. And I think there's
Well, the thing that you need to do to figure out, I think, if I understand your question properly, is you need to correlate or do some analysis to figure out what the flowing capacity of the well is.
yeah.
Because you frack the well, you've got connectivity that you put in place, and you've got probably pretty consistent reservoir parameters, right? Like the permeability and stuff
Yes.
from well to well. So like your well is able to produce, say, 2,000 barrels a day through the fracture network and the matrix, right? So if you're getting 3,000 barrels a day, the extra 1,000 is coming from somewhere else.
Right.
But what that needs to do is that has to tie back to the work that David was showing, where, like some of these wells in the middle have got significantly larger stimulations.
Yeah.
Right. So they can produce higher rates just because they were fracked and they're draining a larger volume, right? So you have to normalize that out. But this is all stuff that's capable, you're capable of doing in Microsoft Excel, really. Normalizing stuff to the total surface area, even if it's something as simple as what David showed. Like I asked him, I said, did you compute the surface areas for these wells, right? Well, if we got those and we have your majestic linear flow parameter type of thing, right? Even if it's just an estimate, it's not coming from the flowing production data, but it's coming from the ICIT model. Okay, we know we stimulated a larger area, we get a higher flow rate, normalize that to stimulated area. Now what's your flow rate? And then you start to compare wells, and you could make a map or one of these gun barrel views or something, along with your injectors. And wouldn't it be interesting if the radial distance to an injector well shows a correlative increase in production rate of water or something like that, right?
Yeah.
All something that we can do. It's not complicated. We don't need to go to Petrel. We can do this all. We can write custom software. We can do it in Excel. Like, we just need the data.
I know. Yeah.
Yeah.
All right, there's, these are case studies that we can do a little bit more, but we move fast and we make decisions, which, I mean, I think we just are missing some opportunities to sort of really strategize about all of this data and have it, like, there's a lot of work that went into this that was, could have been visually done, some of it before we drilled the DSU, some of it sort of most of it after, obviously, on the production data side. But it's still a little strange to me, although we're getting traction and going, hey, this is I'm trying to devise a questionnaire in that when production reservoir engineers come to us and go, hey, these JMs are lousy or MSs are lousy, what's going on geologically? You go, okay, I'll look at that, but what's the productivity index? What's the, did you do any rate transients, and if they get frac hit, there's things that they just jump to, geology, you got all these measurements of logs and, we just jump to that. Must be the intrinsic properties of the reservoir. I'm going, man, possibly, but we need other systematic work done before they come to us, in my opinion, and it's hard because we really, our REs are run hard and they're looking at decline curves and planning the next. Anyway. Okay, enough. Tired.
All right, Doug, well, thanks.
Okay.
And let me know too about you said you wanted to set something up at some point to get your workflow thing going
Yeah,
on.
I
so-
actually opened up our workflow document that we're gonna, get to Beck, and as soon as I start dumping my slides in there, I've just got to schedule a meeting with you because I really, really want to get that done because I wanted a part of our Diamondback workflow, that we do it on all the wells where we have the extra data, NMR, and whatever, and but then we hub and spoke it like I've been doing so laboriously challenging because of my archaic software that I'm piecing together. But yeah, I keep thinking I'm done with caught up on this EOR project, and this stuff comes along and it just grinds me to a halt. But anyway, I appreciate your offer to help because it's the only way we're going to get it done. All right.
Sounds good. All right.
I'll we'll see you next week. Not
All right.
talk to you before. See you guys.
All right. Yeah, bye-bye.